Just like TLC, this is a form of chromatography. This is called chromatography. It's a form of purification. Just like TLC, the stationary phase is again the silica gel, which is this column, and then a mobile phase is added to the column. That is the mobile phase. And then what's going to happen is if your sample's polar, it's going to elute slowly because it's interacting with this stationary phase, which is silica gel. And if your sample's non-polar, it's going to elute pretty fast. It corresponds to a higher RF value on a TLC plate, with like a polar molecule corresponding with a lower RF value on a TLC plate. Alright, so I'm going to be showing you how to pack your column for this column chromatography lab. First thing you want to do is you want to take some cotton. You want it to be a very small piece. Something like that. That actually might be too big. Something like that. And then you want to take it, put it at the top of your pipette column, and then you want to take a longer pipette and use it kind of like to shove the cotton down towards the bottom.
But not too tight.
But yeah, but not too tight. It should be like that. Next, you want to add some salt to the column. You want only like a couple millimeters of that. Sorry. Best way to do that is get your weighing paper and kind of fold it. In there like that, and then you kind of want to use your weighing paper as a funnel. That's the first couple steps of loading your column. Alright, so the next step is going to be loading the silica gel into this column. What you want to do is you want it to be a little less than 4 centimeters, a little less than 4 centimeters. So you're going to take your Sharpie and make a line a little less than 4 centimeters. Right there. And up to that line, you're going to fill up with silica gel. So when loading the silica gel, you definitely want to do this in the fume hood. So you don't want to inhale the fumes. However much you think is going to be amount. Just like that. So after you measure out your silica gel in your column, silica gel is very hygroscopic, so you want to put the lid on right away. And then as for the column, you want a little bit of salt on top of the silica gel, just like you did when you added the salt in the beginning. This is a different technique of measuring out a solid if you don't have one of these. Well, I was going to use it as a funnel. So there's your finished column, and now you want to clamp it in the clamp, and you're going to want to use a paper towel for that. So right here I have our mobile phase. It's 20% ethyl acetate and hexanes, and it's probably a good idea to pour it into a beaker first. You're going to take your pipette and you're going to load that into your column. Loading, this is called equilibrating the column. What that means is you're going to send your mobile phase through the column. It's going to get rid of the air bubbles, and it's going to allow your column to get rid of or get used to the solvent. Okay, so after you load your mobile phase in your column, you're going to want to push it through with airflow. To do that, you're going to have a tube connected to the air, and that is the one with the orange, and then you're going to turn the knob the minimum airflow, like that. Then once your mobile phase is in here, you're going to put it up here, and what that's going to do is it's going to push your mobile phase through the column into this test tube. Okay, as you can see right here, there's some of the mobile phase in the column. What we're going to do is we're going to push it down and to be collected in the test tube with the airflow. What you don't want to do is let your column run dry. After your column is equilibrated, you want to load your sample. You want to use the minimum amount of solvent possible to dissolve your sample, and then you're going to pipette your sample into the column. And then you're going to want to collect it. You want to make sure the pipette is aligned with the tube, because if your liquid comes out and misses the tube, you're losing product. Each time you use airflow, you want to make sure you do not let your column run dry. This is probably the best way to place your test tube when collecting your sample, because it allows you, when the test tube gets almost full, you want to switch tubes. This allows you to do it pretty quickly, like that, without losing too much product in between. So now that we have our fractions, for this example, let's say we have 3 fractions, 1, 2, and 3, and then we got the S, which stands for standard. That we're going to use that standard to compare our fractions to that standard. But what we're going to do is we're going to take each fraction, you're going to spot them. You probably want to do more than 1 pipette full. So spot that same fraction again. Okay. You do not need to wash your spotter in between fractions. So this is our second fraction. Spot that like right here. Okay. Now when you go to spot your sample, this is when you do want to wash your spotter. So this is our standard sample. Okay. So after analyzing our TLC plate under the UV lamp, this is what we got. So this lane is the standard, and then lanes 1, 2, and 3 are the different fractions. Lane 1 shows a compound that traveled all the way up the plate, while lane 2 has 2 different compounds in it, and lane 3 just has 1. Since we know the standard traveled this far, we can probably assume that these 2 spots in lane 2 and 3 are caffeine, just like the standard. However, when you're combining your fractions, you only want to take lane 3, and then you're probably going to have other fractions. We only did 3 in this example, but you're probably going to have other fractions that just contain the caffeine spot. So those are the ones you want to combine in the Rotovap. You don't want to take number 2 because it has something else in it that isn't caffeine. So anyway, after you Rotovap, and you can watch a video on YouTube explaining how to Rotovap, but after you Rotovap, if you have enough material, you want to do either LCMS and NMR, or just LCMS if you don't have enough.